We use the power reducing formulas, or the formulas for lowering powers that you see right over here, for writing trigonometric expressions as a single power of cosine. Notice that all of these change a squared expression to a single power of the cosine of 2x, the cosine of a double angle. So sometimes you can use the double angle formulas in conjunction with these if you wanted to change it again. So let's do this example first. Write sine of the fourth x as a single power of cosine. The first thing we need to do is look at it algebraically and realize sine to the fourth x is equal to sine squared x squared, or sine squared times sine squared. Now we can easily use this formula right here. Sine squared x equals 1 minus cosine 2x over 2. That's all still squared. Remembering that when we square a fraction, we square the top and square the bottom. Now, once we've simplified this expression by squaring the top and squaring the bottom, we've got 1 minus 2 cosine 2x plus cosine squared 2x. Well, we still don't have our function as a single power of cosine. So you can see that two of the terms on the top in the numerator of this fraction are single powers. This cosine squared 2x needs to be taken care of. So let's take care of that next. First, we're going to deal with the single term denominator. Put the 4 under each of these terms. So 1/4 minus 2/4 cosine 2x, or 1/2 cosine 2x, plus 1/4 cosine squared 2x. The 1/4 is there because we put the 4 under each term, because it's a single term denominator, and dividing by 4 is the same as multiplying by 1/4. So now we're going to deal with this cosine squared 2x. We're going to leave these guys alone and deal with the cosine squared 2x. Using this power reducing formula, we're going to change the cosine squared 2x to 1 minus cosine of 2 times 2x all over 2. Notice here, the important thing to think about is that what's in the cosine squared is 2x. Up here, what's in the cosine squared is x. So when we move it over here, when we use the formula, whatever's here goes here. So in this case, whatever's here goes here, multiplied by 2. You see how the x got multiplied by 2, so we got to multiply this 2x now by 2. So I'm going to move this up a little bit. So you can see that I've got 1/4 minus 1/2 cosine 2x plus 1/8 times 1 minus the cosine of 4x. 2 times 2x is 4x. You can make this a little bit cleaner. There's lots of different ways to write this. Depends on what kind of simplified form you're looking for. If you distributed the 1/8, then you could combine the 1/4 and the 1/8. 1/4 plus 1/8. So now you see all we've got are single powers of cosine. Sometimes you see it with the fractions factored out to the front, and that's also okay, but this is fine for our purposes. Okay, on this page is your assignment from Tuesday night. Well, it's the assignment from page 514 of your text. problems, 11, 12. Well, we just did number 11, but 12, 13, 14, 15, and 16. And I'm going to give you some hints to start each of these off. Just remember, just like the one we just did, cosine to the fourth x equals cosine squared x, the quantity squared. Again, you can deal with this sine to the fourth x in the same way, this cosine to the fourth x in the same way, and then here's two of them, cosine the fourth and sine the fourth. And then cosine x to the sixth power, cosine to the sixth power of x, is going to be cosine squared x times cosine squared x times cosine squared x. I think that's the easiest way to think about it. So before you use the power reducing formula, simplify your expressions to look a little bit like this. Pause it now and do these problems. Here are the answers for numbers 12 through 16. Remember, you can have an answer that's kind of equivalent to this if you have it factored out or if you have it written a different way. And number 13 and 14, one good idea is to use the results from example 4 in your textbook. If you've got the Stewart 6th edition precalculus textbook, the example 4 deals with the cosine squared. Actually, I think cosine to the fourth x or sine to the fourth x, and you can just use the results from that example to replace one of those two terms in the product. So these are your answers. Please take a minute to go back over them, find another video, whatever you need to do to be proficient at this by the time you come to class. Next.